Welcome to Brain Vision.
Okay, so we're in chapter 37, problem 90. It says visible light incident on a diffraction grating with split spacings of 0.012 millimeters has the first maximum at an angle of theta equals 3.5 degrees from the central peak. If electrons could be diffracted by the same grating, what electron velocity would produce the same diffraction pattern? Okay, so the wavelength is found from equation 3513, and the velocity of electrons with the same wavelength is found from their momentum, assuming they're not relativistic. So we have d sine theta, and this equals n lambda. We can rearrange this. Sorry, excuse me. For lambda here is d sine theta over n. And relating this to the de Broglie wavelength of an electron, we say that this must be equal to h over p. And if we assume that they're not relativistic, then we can use this h over mv. If that's the case, let's rearrange for solve for v, and that becomes hn over md sine theta. Okay, so let's figure out what the speed is here. So h here is 6.63 times 10 to the negative 34 joule seconds. It says we're talking about the first maximum, so n is just 1. The mass is 9.11 times 10 to the negative 31 kilograms. D was 0.012 times 10 to the negative 3 meters. And then we have sine of 3.5 degrees. So everything here, double checking, is in SI units. So this comes out in SI units as 990 meters per second. And since this is much less than the speed of light, we can assume our classical approximation is good. If this was a little bit closer, like maybe 10%, 5%, 15% the speed of light, then we probably should go back and replace our equations with the relativistic ones. But in this case, we're all good.